Now for question 1, alright, for question 1, if you observe, this is going to be under simple harmonic motion. Simple harmonic motion, SHM, for both alternative A and alternative B. But the only differences might be that you might not use all of this. For alternative A, it might be simpler. For alternative B, it might be more difficult. But you should know that in either case, what you are going to do here is simple harmonic motion based on the apparatus given to us. You need stopwatch, you need two retort stand. One, you might need only one. You need thread, you need two identical spiral spring, you might need only one, or you might not even need them at all. A meter rule, then these masses, okay, you might need all of them, or you might not even need any of these. You might only need the pendulum bulb, then two screws of uniform thread. You might not need this. Then stopwatch, very important, optical pin, and plasticine. So these are the apparatus we are told to get for our practicals. Now take note of these practical tips. Please screenshot it and then make sure you go through it on your own leisure time, and make sure you abide by these instructions. They will help you to pass adequately. So let's delve into the practicals directly. So for question 1, I expect that since we are using two spiral spring or whatever, one of the questions might come in this format. Okay, we might need a clamp with a meter rule. Okay, either we need two clamps or we might only need one. Then with two spiral spring or even the two. So take note of this particular diagram. Alright, so you have your clamp with a meter rule, you have your spiral spring, your pointer, your mass, and then you have this mass dangling on this. So if it comes this way, a spiral spring is suspended vertically from a rigid support and a meter rule is clamped vertically in front of the spiral spring as shown in the figure above. With no mass attached to the spring, the position of the pointer L0, without this mass, L0 is expected, that's the height from the maximum height here to the part where the spring ends on the meter rule is read and recorded as A. Then mass M equals 100 grams. You now suspend 100 gram mass on this at the free end of the spring, and the new position of the pointer L of the loaded spiral spring is read and recorded. The suspended mass is set into vertical oscillation and the time T for 20 complete oscillation is measured and recorded. Now if you look at it from the white paper, you will see that our masses for this year are what? We have 150, 200, 250, 300, and 350. So expect these masses to be given to you. So if you're able to achieve that, then what do we do next? The procedure requires you to repeat for M is 200. If you observe, the masses for this is 200, 300, 400, 500, 600. While for this we are 150, 200, 250, 300, and so on. So please take note of this variation, but the practicals are similar. Remember, your L1 is your new height, then or the increased height. Your L0 is your original height. Please take note of this. So measure and record the real value of L0, which you are meant to do at the beginning. Measure and record the real values of L1 and the corresponding values of T1 based on the time you were able to obtain the 20 oscillation. In each case, determine the period T of oscillation and evaluate T squared and E equals L1 minus L0. So your new height minus your original initial height. Exactly. Before you depress this or stretch it, merely you hung the mass. This height, this spring is expected to stretch. Exactly. So what it means is that without the mass, you have your L0. Once you attach the mass, this spring will be stretched. It gives you your L1. Okay, that's what you are going to use here. All right. Then before you begin to oscillate vertically to get your 20 oscillation and your time t1, please take note of this particular aspect. Then plot a graph of E on the vertical axis against T squared on the horizontal axis, starting both axes from the origin. Alright, determine the slope S of the graph. So you are expected to state two precautions you would take if you were to perform the experiment in the laboratory. Of course, you perform the experiment, so you state the two precautions. You can be asked to explain what is meant by the period of oscillation of an oscillatory body. A spiral spring is compressed by 0.02 meters. Calculate the energy stored in the spring if the force constant K is 400 Newton per meter. So for simple harmonic motion, you are expected to set up your experiment this way. Alright, you can see your spring, your mass attached, then you can depress it a little and release to obtain up and down vertical motion. And then your period or your time given might be 20 seconds or even 10 seconds depending on how WAEC we set their question. So what you are expected to do is to be varying the masses. Alright, as you obtain your values, you vary the masses and then you take notes of your time. Okay, your stopwatch must be working perfectly. Is that unclear? Then you depress and release. You begin to count 1, 2, 3, 4. When it goes up and down, it has to complete one oscillation. Please take note of that. Exactly. If you depress downward, it has to go upward, then downward again before you count 1. So please take note of this so that you don't miss your values when you are counting for this particular practical. So depress and release. But immediately you attach your mass, you are expected to take the reading of your extension. So you keep varying the masses, you keep adding or subtracting your masses as given from the question. Your table is meant to look like this. Your masses, capture it on your table. Then your L1, after you attach your mass, the new height of the spring, you record them for each mass. Alright? Then your L0 original height, you record it and attach it. Then your time in seconds, okay, using your stopwatch for 20 oscillation, this is your time. Is that one taken? Then your period is time over the number of oscillations, which will give you this table. Then your t squared, you are going to square your period, which will give you this particular table. Observe the values. They are in 3 decimal places. Make sure you do that. Okay? If they are clashing, make sure you use 3 decimal places or 2 decimal places. Then your E is L1 minus L0. Your L1 43 minus 39 gives you 4.0. Then let's look at this part now. If you look at this next one, you will see that 47 minus 39 will give us 8. 51 minus 39 will give us 12. 55 minus 39 will give us 16. 59.5 minus 20.5 minus 39 will give us 20.5. And then 63 minus 39 will give us 24. So the graph line is the line of best fit that I'm going to draw. So we have been told to plot a graph of E, which is the extension. Now this one, this is giving you a clue of uh, elasticity, which you have F, which normally you know that F equals what? Ke. Are you here? So please take note of this particular experiment. It might come in this format. So if you're able to understand this concept, this becomes your extension. So you are plotting a graph of where is it? Extension against period. Sorry, you are plotting a graph of extension on the vertical axis against t squared on the horizontal axis, extension against this. So if you're able to achieve this, this is how your graph will look like. All right, your graph will be a graph of E in centimeter against t squared in s squared. Your scale can be 4 cm for 5 units on the vertical axis and 2 cm for 0.200 units on the horizontal axis. So this is how your graph will look like. Make sure you use the whole of your graph. Is that clear? Then your line of best fit is going to look like this, a straight line. Yes, it might not start from the point of origin. It might start on the x-axis or the y-axis, depending on how good you are able to carry out your practical. And your slope will give you this. Your slope will come from the line of best fit. So pick the outer one and the last one that falls on the line of best fit as your slope. So you get the value and you calculate for your slope. So for slope, we're going to have the slope of what now? We are plotting what on the vertical axis? The slope of extension against period squared. So S equals E2 minus E1 over T squared 2 minus T squared 1. And if you do that, you have your values here. So your slope is going to give you a clue as to the force constant when you use your formula to calculate for this. The precautions taken under this, I would ensure that the mass is depressed only slightly. You say I ensured that the mass is depressed only slightly, which is small amplitude, and then released to set it into oscillation. These are your precautions. Then I avoided error due to parallax in reading my stopwatch and meter rule. I ensured that the mass was not distorted during the oscillation. Please, this one is because this was alternative to practical, but this one you are carrying out the practical, so your precaution must be well written. Remember that the period of oscillation of an oscillatory body is the time taken for one complete cycle of oscillation or the time taken for one complete to and fro movement of the body. The energy stored in spring equals half kx squared. And if you do this, you have this as your answer. You can see it's a very simple practical. So make sure you are prepared on this. Now, if your practical doesn't come in this format, this is the one you will expect. Very simple. You would expect this one, okay, where you just have your origin support. Okay, you might likely also have something similar to this. All right, just take note of this. You might have something like this. It might not come this way, but just know that these are different alternatives that can come out in WAEC. All right, it has to do with either up and down motion or to and fro motion as simple pendulum, where you have your retort stand, exactly, and then you hung your pendulum, okay, on the cock, and then you measure the height. You'll be told to measure this height, exactly, and then the height from the floor will be give you y, and then the height from the retort stand to the floor also give you capital letter H. So the practical can come in this format also, and then you put this into oscillation. So you'll be having something like this. You take 20 oscillations also, and your table is going to look so similar to this one. Is that clear? It's going to look so similar to this one. But here, your E, which is extension, will be converted to this Y. Okay, because you are going to subtract your what? Your H from your Y. If you subtract your H, okay, from this particular part, then you will obtain your Y and you record it. Is that clear? So you can be asked to plot a graph of T against Y also for this particular practical. They are similar to each other when it comes to this, but they are all under simple harmonic motion. So I believe you are aware and prepared for these particular practicals. Check the next practical for question 3. You are expected to answer only 2 questions, but any of these can come out in the exam. So go through them all to get yourself adequately prepared.